In this video, we're going to learn Unix loops. We left off in the molecules directory. Let's go one level up and then cd into the creatures directory. I want it to be inside of data shell / creatures directory. In here we have two files, basilisk.dat and unicorn.dat. Let's say we want to rename both of them. We want to move basilisk.dat into original basilisk.dat, and then similar for unicorn. We want to move unicorn into original-unicorn.dat. If we have only two files, we can do this manually by hand. But imagine you have 1,000 files here instead of two files. Then obviously doing this by hand will be extremely tedious. Fortunately, in Unix, in Bash, you have a concept of loops, like in any scripting language, and it's very easy to use. So let me type for file in *.dat, then I hit enter. Notice that my prompt changed to the greater than sign. So this means that Bash is expecting me to finish my command. I haven't finished typing it yet. So here I'm cycling through all .dat files. Then I'm going to say do, begin the actual loop, and then my loop will contain a single command, echo $file, and then finally I say done, and when I hit enter, my loop will run. Here I'm cycling through all .dat files, and for each file I'm running echo, printing the value of the variable file. So file is a loop variable, and the reason why we have the $, let me show you on a simple example. Let's say we create a variable called ABC, and we set its value to high there. So now if we want to print this value of the variable ABC, we can say echo. If we try typing echo print the variable ABC, it will simply print back the characters ABC, because echo will simply print back anything we pass to it. To print the actual value of the variable ABC, we're going to prepend it with the $, echo $ABC, and that will print its value. This is exactly what's happening in this loop. Here, file is a loop variable, and we're simply printing the value of this variable at each iteration. Since there are two files, there are only two iterations. Let me cycle up to the loop, and notice that when I use the up button, this in history was actually recorded as a single command. So the entire loop is a single command, but then it's separated. So individual commands there are separated by the semicolons, except that there is no semicolon after do. Okay, so when we run this loop, it simply goes through all .dat files and prints their names. Let's do something slightly more complex. Let's have a couple of commands inside of this for loop. I'm going to say for j in .dat files, then do, and let's print the name of the file. So this time our loop variable is j. Let's print ls-l on this file. So that is, we are printing various attributes of this file. And then let's have echo an empty line. So printing nothing, just an empty line. And then we say done. So here we have two loop iterations, and each loop iteration we're printing the name of the file, then various attributes of this file, permissions, timestamp, file size, etc. And then we have an empty line. So here we have three commands inside of the for loop, and this is perfectly okay. Okay, so now we know how to rename our files. Let me clear the screen. Let me start from scratch. So I'm going to say for file in all .dat files, do, and then we're actually going to move the file into original $file, and then I'm going to say done. And now when I type ls, you see that both files were prepended with original dash. Okay, so now let's say we want to move them back to their original names. We would organize a simple loop, except that now we are not adding something to each file name. We're actually subtracting something from the file. So we need to know how to use substrings in Bash. Okay, so let's recall our variable echo, $ABC, the variable ABC, which is high there. Let's try the following syntax. ABC 0, 3. So these will print the first 3 characters. Let's just do 4 characters. The first 4 characters. So starting from character 0, the first 4 characters. Let's use the same idea here in the loop. We're going to say for file in all .dat files in the current directory, do, and then we're going to move each file into a new name. So I'm going to say round brackets, file, and want to keep only the last few characters in each file name. So let me try this. Let's say I want to keep characters from 5 and then up to some large number. But now, actually, instead of running this command, I'm going to prepend it with echo. So this is a test run, a dry run. Instead of running the command, I'm simply going to be printing this command. And then I'm going to say done. Okay, so the command move original basilisk into, so here we actually have to, there are 4 characters that we don't need at the very beginning of each final file name. So we have to change 5 incremented by 4. We have to change it to 9. So the command we're going to run is this one. So this is still a dry run. We still have the original file names. And to actually run this move command, all we need to do is remove echo. Okay, so here we're cycling through all .dat files, and then we are moving each file into something without the first 9 characters. Okay, it worked, and here we have the original file names. In for loops in Unix, the syntax is actually very clear. You're saying for, then a loop variable, in, and then some collection. So a collection can be a list of files. So in this case, we have a list of files returned by a pattern. Before this loop, before this Unix loop runs, this pattern, this wild mask, *.dat, is actually expanded into all possible matches, so into the list of .dat files in the current directory. In principle, you can replace this with any other collection. So a collection could be an explicit list of items or a range. Let me give you an example. If we're going to say echo curly brackets and then have numbers from 1 to 10, this is a collection of numbers from 1 to 10. Also, I can have several distinct numbers. So let's say 1, 2, and 5. And this is also a collection, so you can actually cycle through this collection. So for example, you can say for I in 1, 2, 5, do, and then print I, and then done. We can also use ranges with characters. Let's say a list of all characters from A to Z. This notation is called brace expansion in Unix, and it's super useful because you can actually use it to automate things on the command line. So for example, if you want to create a bunch of files that are called a letter and then let's say .txt, what you can do is you can say touch, then the first character runs from A to Z, and then they all have ending .txt. And this is equivalent to running touch A.txt, touch B.txt, and so on. And then the result is that you have 26 new files, and they're all empty files, obviously.